Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try these problems in your notes, and then unpause it to do them with me. Okay, if EG is equal to FH, so EG is equal to FH, alright, so if these are congruent, if the diagonals are congruent, is trapezoid EFGH isosceles? And explain. That's exactly what the isosceles trapezoid diagonals theorem says, is if the diagonals are congruent, then we have an isosceles trapezoid. So yes, the isosceles trapezoid diagonals theorem says so. Yes. Okay. And if the measure of angle HEF is 70 degrees and the measure of angle FGH was 110 degrees, is trapezoid EFGH isosceles? And explain. Well, what we need to think about is the fact that these sides are parallel, because that means that I can think of this side as a transversal, and then I have supplementary angles here. These consecutive angles must be supplementary. So if I want to know, what is F? I have 180 minus 110. F is 70 degrees. Oh, wait, so these base angles are congruent. And if one pair of base angles is congruent, then I know that the trapezoid is isosceles. That's what the isosceles trapezoid base angles converse tells us. And I mean, we can solve this by the same logic if EH is a transversal, or I think of it as a transversal. These are consecutive interior angles, and they are supplementary. 70 plus 110 is equal to 180. So yes, because the base angles are congruent, and that's the isosceles trapezoid base angles converse that says this. Awesome. Good review of what we did in the last video. Now let's move on to what we have for today. We are still in section 7.5, but we are finishing it, and we're actually finishing all of chapter 7 with this video. So 7.5 was about trapezoids and kites. In the last video, we talked about trapezoids. In this video, we're going to talk about kites. So our learning target is that we know what kites are, and our success criteria is that you can use properties of kites to solve problems. So what are kites? What are their properties? How can we use them? So let's jump right in to what is a kite. A kite is a very interesting quadrilateral. All the shapes that we've talked about from 7.2 through 7.5 have been quadrilaterals, four-sided shapes. So a kite is a special type of quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. Remember, if opposite sides were congruent, we would have a parallelogram. A kite is not a parallelogram, so we cannot have opposite sides congruent. Opposite sides are not congruent because this would give us a parallelogram. And we don't want a parallelogram, we want a kite. So notice that consecutive sides, the sides right next to each other, are congruent. So consecutive you can think of next to each other. The sides that are next to each other are congruent, but opposite sides are not congruent. That's what a kite is. All right. Some theorems about kites. The kite diagonals theorem says that if a quadrilateral is a kite, then its diagonals are perpendicular. Now, if its diagonals are perpendicular, does that mean that it's a kite? This is not an if and only if. And remember that the diagonals of a rhombus are perpendicular. So we can't say if the diagonals are perpendicular, then it's a kite. We don't know that because kites and rhombuses both have perpendicular diagonals, but they are not the same. Rhombuses are parallelograms. A kite is not a parallelogram because we do not have opposite sides congruent. So if we have a kite, then its diagonals are perpendicular. And the next theorem, the kite opposite angles theorem, you'll notice that we have a lot of opposite angles theorems. But the kite opposite angles theorem says if we have a kite, then exactly one pair of opposite angles are congruent. We can't have both set of opposite angles be congruent because then we're a parallelogram. And it wouldn't make sense. Because we have consecutive sides are congruent, it's not actually possible to have the opposite sides be congruent, or the opposite angles be congruent. So, the congruent angles of a kite are formed by the non-congruent adjacent sides. So in between the congruent sides, the angles that are in between the non-congruent sides, those are the angles that are congruent. So because BC and CD are not congruent, the angle in between them, and A is the angle in between BA and AD, which are not congruent, those angles are congruent. So exactly one pair of opposite angles are congruent. When it says exactly one pair, not more than one pair, not less than one pair of opposite angles are congruent. Okay, let's use these theorems to solve some problems. So, finding angle measures in a kite. We are told that angle E is 115 degrees, angle G is 73 degrees. We want to find the measure of angle D in the kite shown. Haha, good pun, math book. It is a kite, right? But it's also like mathematically it is a kite, so that's funny. All right, well, remember from the kite opposite angles theorem, we know that exactly one pair of opposite angles needs to be congruent. And it's the pair of angles in between the non-congruent sides. So angle D, the measure of angle D is the same as the measure of angle F. Now let's call it X. We don't know what X is. We don't know how many degrees there are, but this is a quadrilateral, right? A kite is a quadrilateral. How many degrees are there inside of a quadrilateral? 360. So we know that X plus 115 degrees plus 73 degrees needs to equal 360. So let's combine like terms. 2x plus 115 plus 73 is 188 degrees. Subtract 188 from both sides. And 2x is 172. Divide by 2. And we have that x is equal to 86 degrees. So the measure of angle D and the measure of angle F are both 86 degrees. Let's check and make sure that we were right. Yeah, because angle E is not congruent to angle G, D and F must be congruent. Measure of angle D equals measure of angle F. Write and solve. So we used X for these. Yeah, we had 2X. It's the same thing. Awesome. 86. Yay. We were correct. Let's go ahead and move on to some very important information that you need to have. Identifying special quadrilaterals. So now we have learned about a ton of quadrilaterals. Look at all these different shapes that we've learned about. And we've learned about parallelograms, we learned about rectangles, rhombuses, and squares. This was section 7.4. This was section 7.2 and 7.3. And these were section 7.5. So, 4 sections on quadrilaterals. Now, there's kind of a flow chart going on here. So, I'm going to erase what I just wrote. If you like that information, you can go back and pause it. So, of quadrilaterals, all of these things below the blue arrows are quadrilaterals. Parallelograms, trapezoids, kites, all of this are quadrilaterals. Now, everything under these arrows are parallelograms. They're quadrilaterals, but they're also parallelograms. And a square, because it's underneath both the rectangle and the rhombus, a square is both a rectangle and a rhombus. Same thing, a trapezoid is a quadrilateral, and an isosceles trapezoid is a type of trapezoid. And a kite is just kind of its own thing. It's not a trapezoid. It's not a parallelogram. It's just a special type of quadrilateral. So, when we think about the properties of each of these shapes, there is overlap within the parallelograms and within the trapezoids. But remember, kites and parallelograms are separate. Trapezoids and parallelograms are separate. Trapezoids and kites are separate. So, we can use this flowchart to help us when we're trying to decide, is this a parallelogram? Is this a kite? Is it a rhombus? What is it? We can use this flowchart. So, we're going to use this in our next example when it loads. There we go. So, what is the most specific name for quadrilateral ABCD? What is the most specific name? So, up at the top here, this is a general name, right? Quadrilateral just means it has 4 sides. As we go down this flowchart, we get more specific. So we know it's a quadrilateral. Can we determine if it's a parallelogram or if it's an isosceles trapezoid? How specific can we get is what this question is asking us. So, what is the most specific name? Well, it is a quadrilateral, they tell us that. Also, I noticed that the diagonals bisect each other. So that means quadrilateral ABCD is a parallelogram because of the parallelogram diagonals converse. When that says the parallelogram diagonals converse says if the diagonals bisect each other, then I have a parallelogram. So we know this is a parallelogram. Can we get any more specific than that? Is it a rectangle, a rhombus, or a square? Let's see. Do I know about the angles? Are these right angles? I don't know if they're right angles, so I can't say anything about it being a rectangle. Do I know that the sides are congruent? No, I don't know that. I don't know that. I don't know anything more. I don't know about the sides or angles enough to say it's a rectangle or square, or excuse me, or rhombus. So the most specific name is a parallelogram. We can't get any more specific than that, because I don't know about the angles, I don't know about the sides, whether they're congruent or right angles, or I don't know. Let's check and see if we were correct. The diagram shows that AC is congruent to CE, BE is congruent to DE, so the diagonals bisect each other. By the parallelogram diagonals converse, it's a parallelogram, we said that. Rectangles, rhombuses, and squares are also parallelograms, but there is no information about the side lengths or angle measures, so we cannot determine. Most specific name is a parallelogram. Booyah. Booyah! So, one thing that I would love to point out is, in this example, ABCD looks like a square. It really does. These all look like 90-degree angles. And these look like congruent sides. But you must rely only on marked information when you interpret a diagram. So these red tick marks, this is marked. It tells me that the diagonals bisect each other. I don't have any marks on the sides that tell me they're congruent. I don't. So I can't say anything. If there's no markings, I can't put anything there that's not there. I can't put a right angle there if there's no right angle there. All right. So, questions at this point in time in the video. Assess your understanding of the learning target and the success criteria. Where are you on a scale of 1 to 3? Do you feel a little bit lost when it comes to quadrilaterals and parallelogram, kites, and woo, and all the different types of quadrilaterals? Are you feeling lost? Like maybe you need to ask some questions? Are you feeling like you understand, but maybe you lack a little bit of confidence? That's okay. Maybe try the homework. And if you're a 3, if you're like, oh yes, it all makes sense, then you are ready to help your classmates, your friends, your family members with their homework. All right, here are some practice problems that you can do to practice the skills that you have learned in this video, all about kites and specific names for quadrilaterals. All right, let's end our video with a launch, shall we? This launch comes from Eleanor Roosevelt, and they say, "The future belongs to those who believe in the beauty of their dreams." You've probably heard this saying before, but I really like it. What does it mean for the future to belong to someone? Well, it means that you have a hold of your future. You know what you're going to do with your future. It is yours to make whatever you want it to be. Your future can be whatever you want it to be because it's yours. You control it. You control your future. So how can you control your future? How are you in control of your future? Believe in the beauty of your dreams. That sounds a little cliche, but if you truly believe, right, you have this dream, you have this beautiful dream that you want to reach. If you believe in that dream, that you can make it, that you can do it, if you truly believe that in your heart and soul, that I can do this, this is possible, and you do everything you can to go for it, your future belongs to you. You can do whatever you want with your future. If you don't believe that, if you believe, future, whatever future has, it's going to happen, I don't have control over it, I just cross my fingers and hope that it works out, then, you're not really in control of your future. You're leaving it up to the universe or to circumstances to decide, what your future will be like. But if you believe in your dreams, you believe in your capabilities, and you believe in what you want, your future's yours. You control it. You can do with it what you want. So, do you want to control your future? What do you want your future to look like? And how? What do you need to believe in order to be in control of your future? So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.